What we've done here is we've taken what is our common technology in linear motor and high-speed technology as a machining centre, and where there would have been a fixed table, we've added a powder bed additive manufacturing system. So we actually can build the part rather than having a block or a fixture put onto the table. We're actually building the part from a plate, and while we're building it, we're actually machining the part.
Who does this concept of manufacture apply to?
Well, at the moment it's selling very well into the plastic injection market, because there we can build a injection mould which conventionally takes 30 to 40 items to make that mould. We can build it in one hit. And also it has the advantage of using the additive technology with things like conformal cooling. Cooling channels are very close to the surface. The ability to change the density of the material, so we can make very low dense material which is obviously porous. We can blow air, or we can blow water, or we can blow any liquid you like through that material.
What sort of materials as well does this machine, or can this machine make and machine?
It can actually, you can use all the materials that are available, powder materials that are available on the market at the moment.
So just give us an example what they might be. Metals, plastics, resins?
So it's metal only, so we're using stainless steel, maragine steel, obviously we're using titanium, Inco 718, aluminium, cobalt steel, so all powder material that's available on the market, steel-wise or metal, we can use on this machine.
And what would be the largest sort of component you could make on here, or you'd envisage being efficient to make?
Well, the build platform is 250 by 250 on this one, Advanced 25, with 185mm depth or 300mm depth. So basically the part could be around 240mm size, a mould of that size. But they have a bigger one, a 60, which is 600 by 600 by 500. This is designed around the sort of market of making components like a V8 engine or cylinder heads or big mould and die parts. So.
And that's the additive side. The subtracting is obviously then the machining. Yes. Is this a 3-axis machine or a 5-axis machine, or what's the capability of it?
We based it on a 3-axis machine. What we do actually, we machine it while we're building it. So we lay down, say, 10 layers of 50 microns, so we have a 0.5 depth of part, and we machine that area. Then we build another 10 layers, and we machine another, in this case, 0.5 millimetre. So as the part is built, we're actually machining to a finished size.
Some might argue that sounds like quite an arduous, lengthy process. Is it?
Well, it's a one hit, so it is. We're only leaving 0.1 stock on the outside of the additive built part. So we're initially taking 70 microns off to leave us a finished pass, and then we're taking a final 30 microns off. So although you could possibly make the part more conventionally after it's been done, the beauty of this machine is you can do areas that you couldn't get to once the part has been built.
That's what strikes me as the major benefit and point here. What about the making of the part, the accuracy, so the overall tolerances that you could achieve when you are doing additive?
Obviously we're using a machining, so we've got the same accuracy we've got in our linear motor machine, so we're talking about 2 microns positional accuracy. And obviously the part, and also while we're building it, we're actually recompensating for the laser. So as we build the part, we put a cross onto a piece of paper, and when we check the position against the machining center position, and if the laser is starting to move off, we then recalibrate the laser. So the part is being built very accurately, around 0.1 millimetre bigger than the final part you want to have.
And then the machining part again, what about a tool changer? How many tools can the machine have? How does that work?
We've got 20 tools on our machines. We're not using big tools, so probably the biggest tool we're using is 4 millimetres, because we're only ever taking 0.1 millimetre stock off. And we go down to 0.5 millimetre currently.
Are you using like an HSK back end? Or?
We've got, it's more like a BT20 size. So we're running at 45,000 RPM. We've got what we call HT taper, which is a short version of a 20 series taper.
And then finally the control. Is it very easy to program something like this? The whole part from start to finish, the adding and the subtracting?
We have our own, surprisingly enough, CAM system called LUMEX CAM. Here you basically import the 3D model, you select the material you want to use, and then automatically it will then do the building and the subtractive part of the machining. So at the end of it all, you get a source simulation. You can check that all the parts you want to machine have been machined. Or if you want to then not machine some areas, you can take those off again. So the decision is you what you do. But it's very, very quick. Once you've got the 3D model, basically back to a selected material, pushing the button, and you go to program.
It kind of strikes me that in days gone by, designers used to design parts around how they could make them. Now you're looking at designing it, well, the shackles are off, aren't they?
They are, yes, really. More and more people are looking at additive. Obviously, more and more designers are understanding the advantage of additive. So more and more designs will come out using all those features of additive machining. So at the end of the day, somewhere around the line, you're going to get a part that's going to have some additive only requirement in it, I think. And that's where we hope this machine is going to sell more and more.
And you have been developing this since the late 90s, I believe, so you're right at the front of the technology path.
We have, yes. In 1998 is when we first developed it as a simple rapid prototyping machine. That time we involved with some industrial partners when we designed it, which is where it went down initially, the plastic injection route, and that's been accepted very, very quickly. Obviously from there now we're looking at component manufacturer, and around 2010 this machine was available in Japan, and we've actually introduced it last year into Europe, and it's been very, very, very well taken up.
Yeah, it's very, very innovating and interesting. Thank you, David.
Thank you, Paul.